Hey everyone, my name is Miles again, back with another video, and today we're going to cover titrations. And so I'll just jump right into it. We're going to do two things. We're just going to discuss titrations in general, and then we'll do a practice problem just to get the hang of it. So to jump right in. So titration. So what is that titration? Or what's the point of a titration reaction? So the purpose of a titration usually is to find the concentration of some substance. Of a substance. And a usual typical reaction of a titration usually looks like this. So you have your acid, usually an acid, it doesn't have to be an acid, but most times it's going to be an acid. You're going to take that and add it to a base, and then you're going to produce some product, and that's usually a salt. And then you're always going to produce water. Because the titration reaction usually is a neutralization. And titration problems can ask many different things like find the concentration, find the volume, but the biggest thing during a titration is really you should find the moles of a substance. So if you find the moles of your substance, that's going to get you to the answer the question's asking. So even if it's finding the volume, finding the concentration, if you know the moles, you can do that really easily. So I wouldn't think about finding the concentration. I would think more of, let me find the moles. So if the question is asking you, oh, what's the volume? First, find the moles. Okay. And usually a titration reaction, how they work is you have your acid, and the concentration is unknown. But your volume, that's known. You know that. And then you have your base, and your concentration for your base, that's known. Your volume is also known. So what you want to find is just your concentration of your acid, for example. And in a titration reaction, it usually looks like this. So usually the beaker houses the acid, the little burette this is what houses the base. And so your goal is just to find the concentration of your acid, and you already know all this other information. And then we're just going to define two definitions that you're going to see quite a lot. The first one is the equivalence point. And then you have your endpoints. So your equivalence point, that's just when your moles of acid is equal to your moles of base. And so this is super important. This is the most important thing kind of to take away from this video, is that your moles of acid is equal to your moles of base after you do a titration reaction. And the reason is because right here, you make water, which is neutral. So since your acid and base are both in equal amounts, that means it's going to neutralize out to make water. And then your endpoint, this is just the point at which the color changes. And the point of the endpoint and the color change is just to tell you when the equivalence point happens. So you can kind of think of them as almost the same. So they're not quite the same definition, but I would interpret them as pretty much the same practically, because the point of the endpoint is to find the color change, and the color change tells you when you've reached the equivalence point. So even though they're not slightly the same, I would try to think of them in a similar fashion. And usually the substance you use to determine when your endpoint is reached is phenolphthalein. So this is what most chemists use to determine the color change, and it's what changes it from clear to light pink. Okay, awesome. So that wraps up just the background information. So now we're going to get into the actual problem. So this is the question. So the question is asking us to find the volume is needed to neutralize CaO2. So what we know, so we have CaOH2 and HCl. So for CaOH2, right here, we have the concentration, check. And then we also have the volume of CaOH2, right here, the 10. So the volume, check. And then for HCl, the concentration, right here, we have that too. Oops. And then the volume of HCl, we also have that. So we have the volume, oh sorry, that's what we're missing actually. So this is what we're missing. This is what we're trying to find, the volume of HCl. And so let's first just write out the reaction itself. So what you're going to do is, like before, we're going to take your acid plus your base and you're going to get a product in H2O. So your acid, HCl plus CaOH2 is going to form CaCl2 plus H2O. And I found CaCl2 because we know Cl has a charge of -1. And we know OH has a charge of negative. And there's two of them, so that has a -2 charge. And so that means to have a net charge of this whole compound, this Ca has to have a +2 charge. And for them to form a neutral compound, it would have to be CaCl2. So that's how I got CaCl2. So awesome, we found the reaction. And now let's just balance it really quick. Okay. So we know we have 2 oxygens right here. We only have 1 right here. So let's just add it 2. And when we did that, now we have 4 H's on the right. And we have 3 H's on the left. So if we add a 2 right here, now we have 4 on the left, 4 on the right. And now we have 2 Cl on the left and 2 Cl on the right. Perfect. So this is the balanced reaction. Awesome. So the big takeaway again is the moles of acid is going to equal the moles of base. So this is kind of what I stick to just to keep me in track. So if you remember this, you can pretty much solve most of titration problems. So let's start with CaOH2. So CaOH2, we know the concentration is 0.185 grams over 100 milliliters. Perfect. So that's the concentration of CaOH2, and then we know the volume. And remember when we discussed earlier, I like to think of titrations as finding the moles. So I always try to find the moles first. So that's another big takeaway is find moles. And then you can find everything else if you find the moles. Okay. And then we know the volume of CaOH2, and that is 10 milliliters. So now the milliliters cancel out. But we're still in grams of CaOH2, and we want to convert to moles. So we have to use the molar mass of CaOH2 to convert to moles. And I I already checked that before on the periodic table, and that is 74.092 grams per 1 mole. Perfect. Grams. And then the last unit we're in right now is in moles of CaOH2. Okay. So we're currently in moles of CaOH2. And remember, the point of the titration is that the moles of the acid are always equal to the moles of the base. Right? So we can use the coefficients up top to determine the ratio. So if we have 1 mole of CaOH2 right here, we have 2 moles of HCl. So if I want to cancel that out, I would put 1 mole CaOH2 on the bottom, and then 2 moles of HCl. And now those cancel out, and we have moles of HCl. Perfect. And then the question and the goal is to find the volume of HCl. And we also have the concentration of HCl right here. And the concentration of HCl is 0.00100, and that's moles 1 liter. We just flipped it around. Awesome. So now the moles of HCl cancel out right here. And now we're in liters, which is a volume. I'm going to actually convert to milliliters though, just to make it a bit easier. So for every 1 liter we have 1,000 milliliters. So now our final answer is going to be in milliliters. And I already did the math on that. And so the math on that, that's going to be 500 milliliters of HCl, which is our answer. And that's going to be the answer. And then just the takeaway that I always like to keep in mind from this is that titrations, the moles of the acid is equal to the moles of the base. And the second one is that whenever you're doing the titration, the goal always just find the moles first. Find moles of substance. So if you find the moles, you can find everything else. Okay. And that's it for the video. So good luck studying, everyone, and I wish you the best in Chem 1B.